Okay, so this is going to be our oral communications over our beetles lab. For a bit of an introduction, the main focus of this lab is over behaviors of the beetles. Behaviors are kind of known as responses to stimuli and environment. The two main types of behaviors, learned and innate, learned being something that just develops over time through its response to environment, and innate being something that's kind of evolved. Flower beetles are kind of known as these pests, and they're attracted to the presence of flower in areas. And our goal of this experiment was to track the behavior by seeing how they respond to the introduction of different variables. So we kind of hypothesized that we compared starved beetles versus fed beetles. We hypothesized that starved beetles would reach the flower faster than fed beetles, well, because they're hungry. And our other hypothesis was that these beetles would go towards wheat flour instead of potato flour, because we read an article beforehand that stated that a diet consisting of only potato starch doesn't allow larvae to develop correctly. And we kind of predicted to see significant results among both of these tests.
And then for this lab, there were 3 independent variables: the starved beetles, fed beetles, and the type of starch. In the first part of the experiment, we used organic wheat flour. The second part, we used potato flour. Then the dependent variable was the percent of the beetles who made it to the type of flour. And then for the controls was the arena, so the long rectangular box. The food amount, which was 1 teaspoon, light, and it was used for room temperature.
So our results showed the complete opposite of what we expected. The beetles preferred the potato flour, which you can see from the bottom graph, and more beetles went to the flour in the fed group for the ones with the potato, which confirms that they wanted the potato more. More starved beetles went to the flour when it was the wheat flour compared to the potato flour. And there's a significant difference between the fed and the starved for the potato flour, but not for the wheat flour. And then there's a significant difference between the fed for the potato and compared to the wheat flour. So again, not what we expected. So we retracted our hypothesis.
Our experiments refuted both our hypotheses. The first one, which was stating that the starved beetles would move faster and quicker to the flower patch, and then the second hypothesis was that they would prefer organic wheat over the potato flour because larvae do not develop well in the potato flour, as mentioned before, and there is a significant difference in beetle response to different types of flour, but they weren't exactly what we expected it to be. The behaviors of the beetles to the stimuli did not support the initial research that we had in the article or the hypothesis that we had, and what we saw were that more of the fed beetles were going towards the flower than the starved, and the starved beetles were just lost. They were going in different directions as soon as we dropped them into the arena, and then the more beetles were found attracted to the potato flower than the wheat flower, which is complete the opposite of what we read in the article. And what we consider errors is that the flipping on the back of beetles was a major factor that played in this, and then we should have given them more time of observation, and the tape in the arenas were attracting the beetles as well, so they were clueless of which way to go.
So tying this all back together, by analyzing these behavior patterns within the beetles, we can better understand mechanisms and what really attracts them and what's their driving motivation for going the direction that they go. And this can be used on industrial scales for preventative measures and countermeasures to those beetle incursions. And our results, as stated previously, did not support either of the multiple hypotheses. But this also could just be because beetles didn't really have any traction upon the walkways. So if we're going to take this research a step further, we could redo the experiment because our results didn't support the article or what we originally had set out to do. And additionally, we could investigate those countermeasures that are being investigated. So for storage containers for these flower units, they could be colder to see if perhaps the beetles would be less attracted or maybe even more attracted.
questions?
I like that shirt.
Thank you.
So do you think that the beetles were more attracted to the potato flour than the organic flour just because it had like potato in it, and that's like something that they would maybe like more than organic wheat?
Yeah, it honestly could just be like a personal beetle preference. It doesn't make much sense why they enjoy the potato flour more, considering, like, we read this whole article, the basis of it was that if a beetle's diet consists of nothing but potato starch, then the larvae won't develop. And so it makes no sense that they would like go towards the potato flour, but maybe they were so used to wheat flour they just wanted a change of palate.
It also could be the instant sense of when we like just dropped them into the potato flour arena, that they just like this strong smell of the potato flour. It was stronger than the wheat flour, so they might just detect it that really soon, and so they just moved towards it.
Do you think that like the sex of the beetles has anything to do with preferences?
Yeah.
It probably does,
Yeah.
especially since in like the article, the Romero article, they only
They were
used
all
females
females.
Yeah.
because there's differences. So obviously we don't know which sex went to the flower,
Mm-hmm.
but it could have made a difference.
Yeah. Yeah, because I was wondering if you just have like a larger proportion of males, then like the larvae development wouldn't matter as much to them, and maybe.
That's great.
Yeah. Smart thinking.
Just thinking, yeah. Cool.
All right.
Thank you.
Yes. Do y'all want to go next? All right, let's pay attention. Take it away.
The red flower beetle is a worldwide pest storage product. If you live in your homes or anywhere where you can't cause any problems. The red flower beetle depends on the environmental conditions to survive and reproduce. They mostly live for 5 weeks in our pest market. So the red flower beetles feel like they are getting bigger and play dead to wait for it. According to Barry, insects go toward groups that give off a scent because they know there's food available in that direction and they like the scent better. This insect behavior is a demonstration of odor-based host food seeking behavior. For experiment 1, our hypothesis is the number of beetles that will arrive to the white flower are greater than the number of beetles that will arrive to the potato flower because of the smell and the taste preference. And our prediction for experiment was the amount of beetles will be born in the white flower because of the smell and the taste. For experiment 2, our hypothesis was the number of beetles will reach the white flower when sand will be greater than the amount of beetles between the flower without sand present, because the beetles will have something to grip onto. And our prediction was the more beetles will make it to the patch with sand than without the sand present.
For experiment 1, the independent variable was the types of flour, which we did organic, white, and potato. The dependent variable is the number of beetles that will reach the patch of flowers in 2 minutes. And the control was the organic flour and the type and size of the arena and the number of beetles. We had 3 replicates, and then we used, for the first experiment, we used a rectangle container, and we put flowers in each corner. On one side of the container, we put three different types of flowers on one side, and 3 of the members had 5 beetles to drop in the container at the same time as the other member recorded the time for 2 minutes. And after 2 minutes, we recorded the number of beetles that reached the patch and repeat this experiment 2 more times. And for the second experiment, the independent variable was the types of flour, which we did the same 3, and then we added the sand on all the petri dishes on the bottom. And the dependent variable was the number of beetles that will reach the flower patch in 2 minutes, which is the same as the first experiment. And the control was the organic flour. And we had 3 replicates of it. And we used, instead of using the rectangle container, we used a petri dishes, and I filled the bottom with the sand and added a spoonful of the flowers, the 3 types, and we did the same thing pretty much at 5 beetles. At the same time, recorded how many reached the patch.
So our results really weren't significant. For the first experiment, the averages did support our hypothesis, but the p-value over t-test for all of them were greater than 0.05, so they weren't significant at all. Then for the second experiment, the average for the average number of beetles that went to the white flower were the same number as it was in the first experiment, so it didn't reject or support our hypothesis. We ran a t-test to see if there was any significance between that data, and it was 1, so it wasn't. The organic flower control and the white flower averages were the same for this experiment. Not really sure why. But it showed that the average for the second experiment showed that the beetles preferred the potato flower better.
So for an explanation, the data we collected didn't really support either of our hypotheses because there wasn't really any correlation between any of our results. This could be because they just weren't hungry enough, or they were too stressed when we dumped them in to go straight to the food. They just flipped over on their backs. And then for some implications, this could be useful for pest control. In order to use the best deterrent, we need to understand the behavior of the beetles. Some errors, the smell of the tape they were really attracted to, so they would just go straight to the tape instead of the flower, and they kept falling on their backs, so when they flipped over, we would flip them back over, and it was just, yeah, and then maybe they just didn't have a preference to any of the flower types we used. They liked them all pretty much the same, maybe. And then for further investigation, we could try beetles that were starved for 24 hours, or use a different type of beetle, or maybe more beetles, or record how long it takes them to reach the flower instead of how many reach the flower in a certain amount of time. Any questions?
Was there a particular reason why you picked the flower types that you did?
Not really.
Okay.
No, not really. We just kind of thought they'd be good ones to use.
So why did you use, or like, why did you put the sand at the bottom instead of just like putting the flour?
We thought that it might like affect how like fast they can get there. Like it gave them something better to grip onto, so we thought that maybe more could reach the flower in a certain amount of time, but not really.
All right, Jeff.
Yeah, so both of the groups that have gone so far like mentioned the tape attracting them or whatever. That'd be interesting to test to like trap them. Right? But I found I taught one time and we actually saw a bunch of beetles like avoiding pen markings on their like when they would put like little marks in the arena to kind of like mark distances or whatever, and the beetles were avoiding the pen, and we like did some research and realized that some ink in pens is made from crushed up beetles. It's like pretty gruesome, but you can learn some interesting things when you watch the beetles. So maybe there's something to the tape. Sorry, this is not the right thing. Yeah. I just want to like dump them onto a tray and like put pen all the way around them and see if they'll like outside. Yeah. I haven't done that yet. It seems mean. I don't know.
did beetle behavior within differences in temperature. We did 37 degrees Celsius room temperature and 4 degrees Celsius to see which one was the best for beetles to move from one side of the petri dish to the flower.
So as we know, red flower beetles will typically behave in response to a stimulus occurring outside and around them. This can be anything from temperature, type of food, stress, airflow, etc. Flour is typically their main food source, and we found an article that said they're normally found in warmer, dry environments. So we kind of played off of the ultimate causes to get our results and hypothesized. And our hypothesis was that warmer temperature environments would be more conducive in allowing a higher percentage of red flower beetles to reach the flower patches, due to the red flower beetles typically being found and acclimated to warmer environments.
Okay, so for our methods, our independent variables, Nick said, were the 4 degrees was the coldest, 37 degrees. Now it should have been 4 degrees, and then 23 degrees, and then 33 degrees, 23 degrees is the room temperature. And then the dependent variable was going to be the proportion of beetles that reached the patch on the flower. So proportion, which was a ratio. So let's say we had like 3 beetles go to the flower. We do 3 out of 10. We get 30. That's how we did the statistics. So our controls used were the flower, and then our arena setup, which was in a petri dish. So we would dump the beetles right here, and then see what they would do. So we had 6 replicates, 3 in the cold environment, and 3 in the warm environment. 10 beetles each replicate. So on Tuesday, we allowed the beetles in the cold group to sit in the refrigerator for 45 seconds. We didn't think that would be too harsh, too cold for them. And so the room temperature group just waited, sat, not altered their temperature at all. And then we placed them on the side of the arena that didn't have any flower and watched for a minute. At the end, the number of beetles were counted that were in the flower and calculated into a percentage. And so this was repeated 3 times for the 6 replicas. So as we go on today, we essentially did the same thing we did for Tuesday. Same number of replicates. Once again, we allowed the beetles in the warm group to sit in the incubator for 45 degrees. Not too hot, hopefully. And then the room temperature group wasn't altered at all. And so they were placed in the arena, same thing, same side. And then we waited for a minute, we observed them, and then we calculated the percentage, and then we repeated the same thing 3 times for the 6 replicates.
So our results that we found, the top graph compares is Tuesday's data, so the room temperature versus the 4 degrees Celsius group. And then the bottom one shows room temperature versus the warmer environment. And so we performed t-tests. So the t-test for the first one was 0.113. And if you can see up there, the error bars don't overlap. So the data was very close to being significant. However, when we ran our 3 replicates, the 3rd replicate was 30%, whereas the other 2 were 10%. And so we think that could be an outlier that may have skewed the data a little bit and caused it to be not significant. However, the one that we performed today, the p-value was 0.77, and the values were a lot closer, and you can see there that the error bars do overlap. So as I just stated, the graph shows that the room temperature group for both of them had a higher proportion to reach the flower. than both the cold and warmer groups. Although there was no significant difference in either one of them, the first one was supposed to be significantly different. And like I stated, the possible outlier in the third replicate, that was a 30% versus the 10%. And also you can see the greater difference between cold and room temperature versus the warmer environment room temperature. So through that data, we refute our hypothesis because we have no statistical significance. Also, we predicted originally that the warmer group would have the highest proportion to reach the food. However, that wasn't the case, as the room temperature was higher than even the warmer temperature.
There was no statistical significance because we only tested on 1 minute intervals. We only tested 10 beetles at a time. And when we put them in the warm or cold incubators, we pulled them out and then tested them in the room temperature. So for like future experiments, we would like to see like more beetles tested at a time with more replicates and a larger area, larger than just a small petri dish. And then test the beetles actually in the warm and cold environments instead of pulling them out and then setting them on a table in room temperature and let them acclimate to room temperature. And then test things that deter beetles instead of what attracts beetles more, what's best for them. And with those future experiments, there could possibly be a better solution to the pest problems that beetles provide in the grain mills.
Any questions?
So you mentioned they liked, you said that they like warm and wet environments or warm and dry?
Warm and dry.
Warm and dry. So do you think there could have been like, they may have liked the room temperature situation better because it could have been more dry environment?
Maybe. Or
Yeah.
we didn't see like an actual temperature that was normal to them, so it could have been too hot because we used the hottest incubator that was, just because we thought that would enhance their abilities.
And also, we only left them in there for 45 seconds, which I think, well, we left them in 45, we did that because we left them in the cold 45 seconds also, but they can probably be left in hotter environments longer than colder and survive. So really we could have left them longer in the hotter environment, and so maybe they didn't get warmed up enough to make a difference in that.
Yeah, I know you didn't measure this, but did you notice like the cold versus the warm? Like, was their movement any different? Like, did it take them a little bit longer to get started, and but then they made it to the flower still, or
It took
was there
the
any?
cold like a really decent amount of time to do anything.
Mm-hmm.
And then if they did start moving, like sometimes they would get there or they were just too slow.
They're a lot easier to deal with than
Yeah.
hot.
Yeah.
Like, I'll say that because I do all the work.
You don't have to let
Especially-
me. Okay, cool. All right, good job.